I'll blame the leather jacket on you, man. Okay, so we're going to label. I'm going to start over because I forgot. I'm going to label these components. M already said that in this equation, this is my dependent variable. And the reason why it is the dependent variable is because it's dependent upon x, which is the independent. That brings us back to where we were. So what is -8? Tristan. -8 is my rate. So if it's negative, is this a graph that's going up like this, or is it a graph that's going down like that? It's going down, yes. As x increases, y decreases. That makes that a downward sloping graph. And then the last thing is, what is 6? It's the y-intercept. And remember that y-intercept is where I put 0 in. If I put 0 in for x, what do I get for y?
0.
6.
Oh,
no,
yeah,
because that's what's left over, right? This turns into 0. I get 6. So 6 is my y-intercept. And we're going to learn a little bit more about that today. Here's the big one. How do I find my rate? And I've talked about this to other classes. You cannot. No longer can you just look at a table and be like, oh yeah, I know the rate. Now, you might sometimes, but very, very few. You're not going to see the pattern anymore. Is there a pattern? Yes. But you have to do what we did yesterday to find the rate. So talk to your partner about how do I find the rate, and then I'm going to review it. I like it.
And that's your denominator. And then you, no wait. So you take those numbers and subtract, right?
You're doing a good job, Preston.
And then you do the same thing with the y.
So while I was listening to Preston, Preston said, there we go. Preston said, hey, I'm going to take 2 numbers on my x, and I'm going to find the difference. So it could be any 2. So this one's easy, right? On A, what's the difference between 10 and 0? 10. That becomes my denominator. So that becomes my denominator. Now I have to go to my y, find my numerator. Now I have to pick the same ones. So I have 1 and 31. What's the difference between 31 and 1? 30. I divide and I get a rate of 3. Now, this is what's great. That rate means it's everywhere in this table. So, what is 3 times 20? 60. Now, by y-intercept is 1, I have to add that. So 60 plus 1 is? 61. So do we have a rate here? Is this a linear graph? Yes, this is linear. I could do it again here. 3 times 30. 90. 90 plus my y-intercept, which is 1. 91. So this is a linear graph. Skylar. How do you know it's linear? Because there is a constant rate all the way through x and y. As x increases by 1, y increases by 3.
Wait, how do we know that?
That's what I just showed you what we did. We did a difference of 10 to a difference of 30. I divide, I find a rate of 3. So I know here, right there, there's a rate of 3. So what I'm going to do is I'm going to go down here and I'm going to check to see if that's still consistent.
Oh, I got you.
So I go down here and I say, hey, if I went 20 spaces down in each space, I go 3. 3 times this is 60 plus my y-intercept, which is where I'm at 0 on the x. I add that and I get 61. So we're going to go over one other one. We're going to do B because B is pretty cool. So B, ready? I want you to go with me. Work with your table partner. Find the difference between those two.
4.
Okay. Find the difference between those two.
8.
8. So, ready? With your table partner. Talk about it. Okay. 8 divided by 4 is 2. So, I have a rate right now of 2. Julian, this is the hard part. Do I know my y-intercept in the x? Do I have a 0 in the x? No. But if I go 1 back here, it would be 0, right? Yeah. Okay. So you said the rate is 2. So if I go 1 back here, I go how many back here? 2. So what would this be? 7. Smart thinking. So I'm ready? Here we go. This is the easy part. What's 20 times 2? 40. Plus 7? 47. Do we have a linear relationship? Yes. Yes, we do. Awesome. Now this one's cool. This looks like it's linear because you see a pattern. You see a pattern. You're like, oh, I'm squaring it. But this is not what, it is not a linear relationship. This is an exponential relationship. Exponential means it's squared. It's 3 times 3. But I can show you how finding the rate here does not work. What's the difference between 2 and 1? 1. Difference between 4 and 3? 3. Now, 3.
You said 4 and 3.
Okay, sorry. 3 divided by 1 is 3. So I have a rate here, right here, of 3. Julian, do I know if x was 0, if I go 3 back from 1, what do I get? Negative 2. Okay. So remember the negative 2 because that's going to be important here. So 3. So what's 3 times 4? 12. Add negative 2. 10. It's not linear. Okay? This graph is an exponential graph, and instead of being a straight line like we've been working on, this is a... Yeah. The further I go, the steeper it gets. Okay. Last question. Hairball.
Oh, not cool.
I don't know. Yeah, I'm not even going there. Okay. Since table B does not have a y, does not have a 0 in the x column, what did we have to do to find out what the y was? Talk to your partner.
What was the question?
Huh?
What was the question? Okay.
It's no pattern. No.
You put a number into it.
Okay. So, Skylar, looks like you remembered how to do that. I didn't have a 0, so I have no y-intercept, right? So how do I find the y-intercept? What did you have to do?
So on the x-axis, since there's that 1, you just want to go back 1 to be 0. And then on the y-axis, you just do 4 minus your rate. Or
Okay.
whatever number it is.
Whatever number it is, and I minus my rate, and that will give me my y-intercept. Excellent job. Okay, I gave you guys, hold on, let me stop this.